Okay, so today we're going to look at three-dimensional trig, and what I've done is I've looked at the exercise and I've picked out the very first question, theoretically the easiest one, and the very last question, which will be theoretically the hardest one to do. And to be fair, it actually probably is. All right, so let's look at the first one here. So we've got this like rectangular prism. We're asked to use Pythagoras' theorem. That's great because that's like year 8 maths, right? So part A, let's use Pythagoras' theorem to find the length of the base diagonal BE. Okay, you can see there's a rectangle on the bottom, 12 centimeters across and 9 centimeters wide. And we want to find that base diagonal. Pythagoras' theorem, nice and easy. This is, was that BE? So BE squared is going to be equal to, just square root the whole thing. Okay, you get 15 centimeters. Part A is done. All right, on to part B. All right, so hence find the length of the prism diagonal BH. Okay, so now we're looking at the red triangle. We know BE, the side across the bottom, we just found that's 15 centimeters. And we also know HE, this side here, that's 8 centimeters, right? See how it's written over there. So the height is 8 centimeters. And what they're asking us to do is to find this diagonal here, BH. So again, year 8, hypotenuse squared will be equal to the sum of the squares of the shorter two sides, and you can just square root the whole thing. And this is a pretty common triangle. That's 17 centimeters. All right, final section. I'll go to the new page for this one. Part C, I'll just read it just before I flick over. Find correct to the nearest degree the angle alpha. Okay, so again, we're still just dealing with this red triangle. Funnily enough, we actually know all 3 side lengths now, and alpha is this angle down here. This is going to be pretty simple. You want to find an angle, you only need to know the length of 2 sides. We've got 3, so we can pretty much pick whatever 2 we wanted. Let's just stick with these 2. We'll go over to the next page and let's find the sides of this angle alpha. Okay, so for part C, so we had our triangle already. This was 8 centimeters. This was 15 centimeters. And not that we need it, the hypotenuse was 17 centimeters. We want to find the size of that angle alpha. This is the opposite. This is the adjacent. Opposite over adjacent, we've got ourselves tan, which will be opposite over adjacent. You want to find alpha, move the tan to the other side. And then you just type that into your calculator, press equals, and you're doing it to the nearest degree. So just sort of round it if you need to. And that's it for part C, and that's it for question 1. All right, so for question 12, this one here is noticeably trickier. So you'll go through the rest of the exercise. Questions get progressively harder, and then you get to this one here. So for part A, all right, they want us to, draw a diagram to represent the information. This is great when they do that because you need to draw a diagram anyway. It's better that you're getting marks for it. All right, so point P is due south of the vertical tower. All right, let's start with our tower. Okay, here we go. Here we have tower. Actually, it's 3-dimensional trig. I'll make it 3-dimensional. Okay, here's our tower. And we can have like a palm tree up the top. All right, so there's our vertical tower. Point P is due south of it. And you've got, okay, Q is due east. All right, so it'd be tempting just to put point P straight down the page here. But this is actually a mistake. This is 3-dimensional trig, right? You want things 3-dimensional, so don't draw yourself a 2-dimensional plane in a 3-dimensional question. We actually do want this to be 3-dimensional. So when we're drawing our north-south line, draw it on an angle as if it's actually going into the page. And then, so this would be your north and your south. And then your east and west can cut across just like normal. And hopefully it should actually look three-dimensional. So in this particular case, the tower's going up. You know, you've got your north, your south, your east, your west. And now from this point here, we've been told point P is due south of the tower. Here's point P. And the angle of elevation is 20 degrees. So there it is, there's 20 degrees in there. Point Q is due east of the tower. So I'll do Q over here. And the angle of elevation is 35 degrees. And the distance between the two places, P and Q, was 40 meters. Now what, this is, by the way, this is part A done. Wait, hang on a sec, let me just make sure. Oh, and let H, okay, be the height of the tower. Let me throw in H. Okay, there it is. All the information has been put into a diagram. Part A is done. Now on to part B. All right, so what we have here is a series of 3 triangles. There's the first one. Here's the second one. And the third one's down here. It may not look like it, but this is a right angle here. Right, remember that's east and this is west. That's a 90-degree angle there. It's just three-dimensional. So, dealing with this one here. So, if you look at the bottom triangle, it's a right-angled triangle. We've got the 40 meters. We don't know these side lengths here. I'm just going to call this one X and this one Y. All right, so for this bottom triangle, well, we've got Pythagoras' theorem. X squared plus Y squared is equal to 40 squared. If we look at the triangle that involves P and the tower, all right, so I can see 20 degrees there. So it's going to be a 10 question with 20. But if I look over at what we actually need to show, I don't see any 20 degrees. Instead, I see a 70 degrees. So it looks like we've got ourselves a little bit of a trick here where instead of using that 20, we're going to go up here and use that 70 in there. And it looks like they're doing the same trick with the other one. Instead of the 35 degrees, the actual question has 55. So we're going to be using that 55 degrees up there. All right, so a little bit hard to see, but you know, we've got a 70 up the top of this one and a 55 up the top of that one. All right, so using this triangle that involves P and the tower, we have, and the 70 degrees, we have opposite and adjacent, so that's going to be tan. So tan 70 is equal to opposite over adjacent. And getting x by itself, because I'm looking over here, we don't actually know what x is. So let's rearrange this equation here. X will be equal to h tan 70. Doing the same with a triangle that involves Q and the tower, tan 55 degrees will be equal to opposite over adjacent, and again implying that y will be equal to h tan 55. All right, so we now have expressions for x and y. We can put these into our Pythagoras' theorem equation. So x squared will be h squared tan squared 70. Y squared will become h squared tan squared 55. And the whole thing is equal to 40 squared. Factorizing the h squared out the front, you end up with this. And let me just create some separation. It's getting a little messy here. And now we can, hey, you know, get h squared by itself. And we're one step away from answering what is a pretty brutal question. Square root everything, and you end up with 40 all over the square root of your tens. 10 squared 70 plus 10 squared 55. And if you check back to the question, that is what it's done. And you would then just plug this into the calculator, press equals, and round it to the nearest meter. All right, hopefully that was helpful, and I'll talk to you guys again. Oh.